Today we're going to find your polynomials, given your zeros, but I want to start with something a little bit more basic. So turn the paper over, and I'm going to come up with one myself. What's that? Okay, just make a line and go halfway down then. Okay. Go halfway down. So here are your given zeros. Two and 4. Where do I find your zeros again? On your x-axis. So here's a 2, here's a 4. Now let's see if this makes sense. If I have 2 zeros, what's the highest exponent of my function? 2. If my function has a 2 exponent, what kind of graph is it? Parabola. Okay, so it's making sense, right? Now, when you took apart any parabola, then don't write this down, just let me show you something. If you did this, and you factored this, oops, make this a minus. You factored this. What did this factor into? Three and 2, and then you did this. Agree? And then you found out your zeros over here, right? Okay. We're going to go backwards. I'm giving you zeros, so we're going to start here, right here. X is equal to 2, X is equal to 4. Go backwards. Back me up a step. What are my 2 factors going to be here equal to 0? X minus 2, X minus 4. Okay? Back up another step. X minus 2, X minus 4. Now, if I want, I can FOIL this guy. X squared minus 2 minus 4 minus 6x plus 8. There's my function. Right? I can go backwards on this. So whenever I have a root, I start with x equals. Because where do you find your zeros? Right here, where y is 0. And it's an x-intercept. Now, you also had 2 formulas from algebra. The sum and the product. This I want you to write down. This is really important. And those of you that are studying for Algebra 2, this you're going to need as well. We had 2 formulas to help us get into this. So when we only have 2 roots, we took the sum of this roots, 2 plus 4. And what does that give us? 6. We set the sum equal to negative b over a. Now, we have 2 variables in one equation. We can't do that. So we say, all right, let's let a equal 1. So let's take this out and go like this. So 6 is equal to negative b. Therefore, what is b equal to? Negative 6. Right? Don't I have to divide by negative 1? Okay. Let's do the product. Anybody remember these? You sound familiar a little bit? Product. What's 2 times 4? 8. Let's set 8 equal to c over a. But we said let a equal 1. So therefore, what's c? 8. Right? So, ax squared plus bx plus c equals 0. Plug them in. X squared minus 6x plus 8 equals 0. Isn't that what we came out with? X squared minus 6x plus 8 equals 0. So if you have 2 very nice roots, you can just do it this way, or you can do the sum and the product. Okay? If we have more than 2 roots, we can't use sum and product. So you with me so far? Okay? All right. Now, let's go to your paper. look at this. How many roots do you see? 4. So, what's the highest exponent? 4. So I've got something crossing 4 times. It's probably going to give me that M or that W, it looks like, right? I have 2 rationals and 2 irrationals. Where did this come from? These guys. What are these called? This pair. What's this pair called? They're radicals. What do I call those when they're opposites of the, you add one and subtract one? No? C. Conjugates. Good. You guys are getting there. Conjugates. These are conjugates of each other. This came from a quadratic that I couldn't factor, right? I had to use the quadratic formula. And at the end of your quadratic formula, you know when you get this, negative b plus or minus, and you get this whole thing over here? This came here because I wasn't able to get rid of that radical. So I had a plus and I had a minus. So now, this one's okay. We're going to start like this. This one's okay. We're going to start like this. But these two, we're going to combine into one quadratic. Because if I have to set them equal to 0, it's a little bit more difficult than this one is to get them to one side. You got to do a little bit more. But because they're conjugate pairs, they came from a quadratic function. So these two, we're going to use the sum and the product. So we're going to go like this. Stay with me because it will make sense. So let's take this and add these together. Plus 4. Let's add them. What cancels out? The radical 5s. What's 4 plus 4? 8. So that's my sum. My sum is equal to negative b over a. So let a equal 1. So therefore, what is b equal to? Negative 8. Good. Now, let's do my product. These, guys, come on. These are perfect squares, are they not? Same terms. One's a plus, one's a minus. So I should only have to multiply my first. What's 4 times 4? What's a positive times a negative? Negative. And what's radical 5 times radical 5? 5. So this gives me 11. That's my product. Equal to C over A. Stay with me, we're almost there. So therefore, A is 1. What's C equal to? 11. So I've got a quadratic here, x squared minus 8x plus 11. I got that part right there. So this part over here, I'm going to write down as x squared minus 8x plus 11. How do I bring this guy back to a factor? X minus 2. Just subtract it, set it equal to 0. X minus 2. How do I bring this one back to a factor? X minus 0, which is x. There's my equation. There's my equation. That gives me those roots. We're going to check it on your calculator for you non-believers like Aaron shaking his head saying, oh, that can't be possible. We're going to put this in your calculator. Just like this. When you reach this point, do not FOIL anything, do not distribute. Leave it in factors because look, you can break this down. Watch. Is an x 0? Is an x 2? If I did your quadratic equation on this, I would get those two. I would get that. So if you put this in your calc, it would take a minute for my calculator to come up. But if we put this in your calculator, we should be able to find it. Now I'm going to show you an interesting way to find your irrational one as well. We're going to do it with your value. Because it still has to come across the x-axis, right? And what is the value of y on your x-axis? On your x-axis, what's the value of y? 0. So if we put that in your calculator, we should be able to see that. As soon as my calculator comes up. Now you only have to do the sum and the product if you have two conjugates. You don't want to bring those back the other way because they won't work the other way. So we have x times x minus 2 times x squared minus 8x plus 11. Okay, I put it in just like that and I graph it. I should do a zoom 6. I'll make it life easier. Oh, we said 4 roots. We said it must be a W. It's not even, of course, and that's okay. So watch. Do I have in my table a 0, 0? Let me see. Do I have a 0, 0? Yes. Do I have a 2, 0? Yes. Isn't that a root? My 0 and my 2. Now watch. Go to your graph. Go second calc. Put in number 1. And put this in. 4 minus radical 5. Just one of those roots. That's all you need. If this comes back and says y is 0, bang, I found it. Doesn't my other one have to be 4 minus radical 5? Because they're a pair? But I only have to check one of those. It's irrational, but I still know that it has to happen at the y is equal to 0. So that's a good way to check that. Do the same thing that we did to find your other parts when you did your calc. So that's nice to be able to use. So we said this had 4 roots. We said the end behaviors went up. We said it was a W. And it was just that, wasn't it? All right. Tonight for homework, you're going to do the top of that homework sheet. There's only 3 of them that give you the zeros, and you have to go back and find the equation for it. You can only do the sum and product when you have 2 factors. You can't do it on 3. You have to work each one out this way and bring them back to a factor. The sum and product works for those, the conjugate pairs. Because what happens in a conjugate pair, if you did this, x equals to 4 plus radical 5, and you subtracted it from both sides, you have this, x minus 4 plus radical 5. Now you have another one, x minus 4 minus radical 5. If you have to FOIL that, that is not pretty. So use your sum and product formulas to do your irrational ones, your conjugate pairs.